the Science Guy. Bill Nye the Science Guy.
Science rules.
Welcome back. All right, we are on day 2, exothermic reaction. Task 1, watch the video and fill out the data table. Steel wool and vinegar reaction. All right, so you're going to watch what's occurring here, fill out the data table, the longer, wider data table, and make sure you're writing down the temperature and the observations. Okay, read through the essential question is how can I collect and organize data to determine if a reaction is endothermic or exothermic. Introduction. Make sure you read that. Instructions. 1. View the data table below that will help you collect and organize the temperature and observations of a chemical change throughout the experiment. You're going to do it before mixing the vinegar and the wool, during the reaction, and 5 minutes after mixing. All right. Watch the video. Step 2. Step 3. Record the initial temperature. All right, so I have the initial temperature is just simply room temperature. So that is the initial temperature right here. It looks like 61.7 degrees Fahrenheit, or I was trying to see if I could do it in Celsius, but I'm not able to do that in Celsius right now. 14.5 degrees Celsius, all right? That is the initial temperature. That's what you're going to record in your data table. Okay, so here is some information that I'll talk about shortly. What I'm going to do is I have 60 milliliters of regular vinegar, all right? I'm going to put the thermometer right here. Okay, I don't know if you will be able to see that, but I definitely can. Okay, and it looks like the temperature is that says 16.1 degrees Celsius, so I was only off by 0.4 between the temperature of the vinegar and the temperature of the room temperature. Okay, so then step 2 says to soak, for me on my half, it says to soak the vinegar into the steel wool. Okay, and do that for 1 minute. Okay, I'm going to do that. You're going to be able to see the clock right there. So I'm going to keep this up here on the board as well because this is what you need to be writing down for your observations. Chemical change evidence. A substance that changes in increasing or decreasing in temperature, exothermic or endothermic, producing a gas besides boiling, color, smell, or texture change, because vinegar smells, but if the smell of vinegar isn't changing, then that's not necessarily observation. And change in state of matter, solid to liquid, liquid to gas, or solid to gas, or gas to liquid. All right, so those are 2 things to keep in mind. We have about 15 seconds left, and I'm going to pull it out. Start collecting the temperature data in my Erlenmeyer flask. 4, 3, 2, and 1. All right, so step 3 just says wring out the vinegar. Put that right there. And I'm going to start collecting the data for 5 minutes. Okay, 5 minutes. It's going to start collecting now. So it's at 1 minute and 30 seconds. So at 6 minutes and 30 seconds, we will be 5 minutes into the data. All right. So right now you are going to make observations for the during the temperature. It is a range, so it goes between 16.0 and to be determined so far. Okay. So that is that. I'm also going to use this temperature thermometer. so we can record the temperature. All right, the wool is soggy, okay? You can't really see that from my point of view, so I'm going to just explain what's happening right now. So right now it's increasing temperature. It's up to 17.2 degrees Celsius, or this one has in Fahrenheit has a temperature of 61.9, so it has increased a little bit. I see some discoloration in the wool. All right, the wool, you can see hopefully it turning a different color. It's more of a greenish instead of this gray. I'm going to wrap these around. We've got some vinegar on my thermometers. So we're about 4 minutes and 20 seconds, 4:30 coming up. And it has increased temperature still. It's 17.6 degrees, or it looks like it is now 62.3 degrees. So one's in Fahrenheit and one is in Celsius. I don't care which one you use. I'll try to give you the range. We started at 61.7 Fahrenheit and then 16.5 Celsius. Right now it says 66.7 degrees Fahrenheit. That's during the observation, okay? And then the increase of temperature in Celsius is 18.6. So what is occurring right here? There's, like I said, an increase in temperature. Is it an endothermic or an exothermic? Well, if you're paying attention to what day it is, day 2, it is a exothermic reaction. Exothermic reaction is a release of thermal energy, so meaning an increase of temperature. All right, so let's just keep that in mind. We are at 5 minutes and 30 seconds, so we have 1 minute left. 19.2 degrees Celsius, 68.1 degrees Fahrenheit. So the discoloration of the wool is definitely taking place. Not sure if you can see that too much. I see a little bit of, you can see some condensation around here, so that's like a steam coming off. Okay, so it's definitely releasing temperature, releasing thermal energy, the increasing temperature, and you can kind of see it because the Erlenmeyer flask is getting a little steamy, and it looks like it's getting like kind of rusty or oxidized along the bottom, and that's because there was wool in the Erlenmeyer flask. I used these last year, and this wool itself. So 5 minutes has passed. It is 20.1 degrees Celsius is the final temperature, and 69.6.8 degrees Fahrenheit is the final temperature. All right, so whether doing Fahrenheit or Celsius, either one will be fine with me. Some observations, and we're only doing that for 5 minutes because I think you guys can get the point of what an exothermic reaction is. So hopefully you guys can see these observations. These are a little darker, harder to see, but that is the discoloration of wool. All right, it was a gray shiny color, and I'm seeing like oxidized steel, rust on the steel from the vinegar. Okay, so the vinegar had broke down the outside of the steel, and it had became oxidized. The steel has became oxidized, and it's turning a rusty kind of color. All right, that is the exothermic reaction. Thank you for watching. I will see you tomorrow on day 3 for the endothermic reaction. All right, have a great evening. See ya.